A very good day to one and all. Myself Shahrukh Ali Sayyed from Team OmniDevs. So today we'll be presenting on the topic prompt product recommendation. So the problem statement on which we'll be working works for both offline and well as in online modes as well. Nowadays, customers often struggle to locate very specific product within the vast store premises, leading to frustration and wasting time. Our innovative solution aims at enhancing the in-store experience at Walmart. Along with the offline, if the user wants to purchase anything in the online mode, customers many times needs to find items with some specifications which are not mentioned in the product description. But those specifications can be found out in the user reviews. So what we have done is that we have also utilized the user reviews to provide a better recommendation of the products to the users. So how will be going through so let's see the solution. A solution involves implementing a prompt-to-product system that leverages cutting-edge technology to improve user experience and operational efficiency. So first the user has to enter the prompt, and based on the prompt, the product will be recommended to the user. Both the product description as well as the user reviews will be taken into consideration. Exactly how it will be done, we'll be dealing with it in the further part. So this is our implementation. So the first, the user, when he'll go to the Walmart website, there would be a AI widget at the bottom right corner. The user can click on it to search the product with the help of AI. Then the user has to enter the prompt. So for now I am selecting a previously entered prompt. Here it can be seen the user has entered aluminium body. This sometimes is not present in the product description, but this can be found out with the help of the user reviews. So these are the exact product recommendations, exact products which the user wants to see. It saves the time of the users as well, and it avoids user to going to some other online websites for shopping. It catches the attention of the users. Then this is for offline shopping. The user presses on the shop icon. Then the user, if selects Lays, then here there's a product description as well as the location. So the user can directly go to B wing, second floor, and the price. This could be done by using the data set where the product location and the product description along with the product ID and the product name is entered in the data set. So exactly how we'll be working is shown here. First, the user will enter the prompt. The user prompt will be converted into tokens. That is, the stop words will be removed. Conjunctions, punctuations, everything would be removed. Only important words will be taken into consideration and which will be in a list. Then the product description or the product description of all the products will be tokenized. And then based on both the user prompt tokens and the product description token, we'll find a percentage of matching between the user prompt and the product. And then in the next step, the customer reviews are also tokenized as well for each product separately and stored in a list of dictionaries where product ID is a key. User reviews are all merged together and that serve as the values. These are the unmatched tokens. First of all, the user tokens which are matched with the product description will be removed from the tokens, and the remaining tokens will move to the next stage where they will have to match themselves with the user reviews. And here we'll be using the 80-20 rule. 80% weightage of the product will or 80% weightage would be given to the product description and 20% to the product reviews to create a enhanced recommended list. And the top 5 products with maximum matching percentage will be shown as it was shown earlier in the implementation part. So this is the backend code for how we'll be proceeding with the code. This is string is basically the prompt which the user will enter. Then we'll use NLTK. This is the return tokens function. It will take string as the input, that is the user prompt as the input, and it will tokenize them, remove the stop words, everything and all. And in the next part, for in this case, we have taken a dummy dataset, a small dataset of products and names. As it can be seen, it is a list of dictionaries. The user prompt will be matched with the product description, and then the same thing will happen for the product reviews as well. So here, as it can be seen, it is the prompt has been tokenized, the user prompt, and now it has been provided to this function, and this will return the list based on the top 10 similarities based on the product description only. Now in the next stage, we'll do the same for the product reviews as well. Now these are the results for the product reviews. Here we'll be dealing with some specifications which are not mentioned in the product description, and finally 80-20 rule, and we'll get the final output. So this will be the overall workflow of how everything would work. Each time a user will enter a review on the website, the dataset will be dynamically updated with it, and everything will work as shown here. In offline mode, we'll be considering dataset with these attributes: product ID, product name, product description, product location. In online mode, instead of product location, we'll be using the product reviews. This is the dataset on which we'll be training the model. These are the benefits. It would be time saving for consumers. The consumer will not go away from our website, and we will stay on Walmart itself. They will not go for any other shopping websites and all. It can help employees as well in case of offline shopping, because the consumers will save time and they will directly get the product location. So it will also help in better human resource management. It will also optimize operational efficiency as well. So that this is the GitHub link. The code has been uploaded on this link. So thank you so much from Team OmniDevs. Thank you.